Welcome students, we got an interesting question. We are expected to integrate integral 0 to pi over 2 sine squared x over a times sine squared x positive b times cos squared x times dx. Now to integrate this, foremost what I wish to do is I would like to consider I1 to be equal to this, and I'm going to take I2 to be equal to 0 to pi over 2 cos squared x divided by a times sine squared x positive b times cos squared x times dx. I can always take it like this. Now next let me actually add I1 with I2. Okay, adding I1 with I2 we get, so what do we get? I1 I2 is equal to integral 0 to pi over 2 sine squared x times dx over a times sine squared x positive b times cos squared x positive integral 0 to pi over 2 cos squared x times dx divided by a times sine squared x positive b times cos squared x. Now this can be rewritten as integral 0 to pi over 2 sine squared x positive cos squared x times dx divided by a times sine squared x positive b times cos squared x. Fair enough, right? Now sine squared x plus cos squared x is equal to what? Sine squared x positive cos squared x is equal to 1. Because of that you can apply it over here, and this is going to be integral 0 to pi over 2 dx over a times sine squared x positive b times cos squared x. Now I have made a video as to how we can evaluate this. Upon evaluation, this would give us pi over 2 times root of AB. This is the value, or I should say, when we integrate this integral, this is the value that we would get. The link is in the description. Please check that out. So this would mean I1 plus I2 is equal to this. Now from here we would not be able to extract anything because we need I1. If I were to write I1, then the utmost thing I can do is I1 is equal to this quantity minus I2, but that does not serve our purpose. So now what I wish to do is I would like to consider a times I1, which is equal to integral 0 to pi over 2. I am multiplying I1 with a, so this is going to be a times sine squared x over a times sine squared x positive b times cos squared x times dx. Then I would like to consider b times I2, which is nothing but multiplying I2 with b. So this is 0 to pi over 2 b times cos squared x over a times sine squared x positive b times cos squared x. Of course you need to place that operator dx there. Now adding a times I1 with b times I2 we get. So what do we get? A times I1 positive b times I2 is equal to, you add this with this, so 0 to pi over 2 a times sine squared x dx positive a times sine squared x positive b times cos squared x positive 0 to pi over 2 b times cos squared x over a times sine squared x positive b times cos squared x times the dx. Now you can add these two together and rewrite it as 0 to pi over 2 a times sine squared x dx positive b times cos squared x times the dx divided by a times sine squared x positive b times cos squared x. Now I can rewrite this as integral 0 to pi over 2 a times sine squared x positive b times cos squared x times the dx divided by a times sine squared x positive b times cos squared x. This and this can be cancelled, giving me 0 to pi over 2 dx, which is nothing but x limit 0 to pi over 2, which is nothing but pi over 2. But what is this? This is nothing but a times I1 plus b times I2. This is the value. So I'm going to take this as 1, I'm going to take this as 2, I'm going to utilize this part of the space. So from 1 and 2 we get, so what do we get? I1 plus I2 is equal to pi over 2 times the root of AB. This is 1, and a times I1 plus b times I2 is equal to pi over 2. This is 2. Now what I wish to do is, I would like to multiply 1. I need to eliminate one of this, so I will multiply 1 with b, and then this is going to give me b times I1 plus b times I2 is equal to b times pi over 2 times the root of ab. This is the changed one, so I name it as 3, and I will add it with a times I1 plus b times I2 is equal to pi over 2. You change the sign, change the sign, change the sign, this goes off. This is going to give me b times I1 negative a times I1 is equal to pi b or b pi over 2 times root of ab minus pi over 2. I can take I1 out, I get b negative a is equal to, I will take pi out. In fact, this b can be written as root of b times root of b, right? So anyway, I will take pi out and then 2 out, so that would give me b over root of ab negative 1. So this is the value that we have got. Now we can actually rewrite this one more time. So I will write pi 1 or I1. Now I'm going to rewrite this as a minus b. So a minus b means you have a negative sign, and this can also be rewritten as 1 negative root of b times root of b divided by root of a into root of b, right? So there's a negative 1 there. This negative will become positive. Let me utilize this side and then rewrite the question. So I1 is equal to, push this a negative b down, so pi over 2 times a negative b times 1 negative, now this root of b gets cancelled, giving us root of b over a. Now if you want, you can further simplify this. So what I wish to do is, I would like to show you the simplification here. So this is equal to pi over 2 times a negative b. Now I would like to take the LCM as root of a, so that would give me root of a negative root of b divided by a with the root there. Okay, now this can be further rewritten as pi over 2 times root of a negative root of b divided by a negative b. I can rewrite a negative b as root of a negative root of b times root of a plus root of b. I can do that. Now there is a root a there, so place that. Root a negative b, root a negative root b can be cancelled, giving me pi over 2 times root of a times root of a plus root of b. So that's a beautiful representation, and we got that from here. So since it's definite integral, you can add the term units, right? So that is the final solution to this beautiful question. Thank you, students. Please like, share and subscribe to the channel. Until we meet again, enjoy your day.